So we're going to use synthetic division. And the one thing that I'm going to write up at the top is I'm just going to tell you that when you're dividing by a binomial and we have a plus or x minus or x plus a number, that's when you can use synthetic division. If you're dividing by something else, you'll have to use long division, but you'll get to that next year. So for our synthetic division, it has to be something like x minus 3 or x plus 2. That has to be what you're dividing by. There can't be a number in front of the x. The x can't be squared. It's just x plus a number or x minus the number. So if you have something else, we cannot use this method. Okay. And then we are going to take the number that would have been the root, like what would have been the 0 or what would have been the solution from our parentheses, and we're going to put that in a little box. Okay, so if I had x minus 3, I'm going to put 3 in the box. If I had x minus 2 or x plus 2, what would be the solution if you had x plus 2 in parentheses? What kind of 2? A minus 2. So if I had x plus 2, I'm going to put minus 2 in our box. And you'll see what the box is in a second. So for this very first problem, I'm going to have you guys watch me set it up and work it. And I'm not going to tell you what the steps are at first. I'm going to go really slow. I want you to see if you can figure out what I'm doing. So you need to be focused on the screen for this first problem. And I want you to see if you can understand what's going on and how I'm getting the numbers that I'm getting. Okay? So I'm going to start this first problem. You can go ahead and write the first problem out. You can go ahead and do that. But don't write it down until we're done, until I'm done working it, the whole thing. So write the actual problem. A cubed plus 14a squared plus 41a minus 56 divided by a plus 8. All right, do you all have it written down? Okay. Oh, and just a tip for you guys, if your screen is really, really small and it's hard for you to see, if you have an HDMI cord, like a long one, you can plug it into your computer and then your computer can be on your TV. So if you're in a room where there's a TV, you just plug your HDMI cord in there and then you have it on a big screen. It's easier for you to see rather than on your little one. So just an example, you could use that just to make things a little bit bigger for you. All right, so here I go. I'm not going to tell you the steps right now. I just want you to watch and see if you can figure it out. We got a lot of bright folks in here. I bet you can do it. Okay? So don't write it down until I'm done. I just want you to watch. Everybody see what I did so far? Where those numbers came from? Okay. Anyone think they have any idea what happened in the process? What did I do with the 1 at first? I took the 1 and I dropped it down. Okay, so you take your first number and you drop it down. So y'all can go ahead and drop your 1 down. Actually, write your top row. So write your top row, your coefficients. Then we're going to drop our 1 down. Okay. And then I say 1 times -8, and I put it underneath the next number. So 1 times -8 is -8. And then I'm going to add together these numbers that are on top of each other. 14 and -8 together make 6. And after that, you repeat the process. So whatever number you have on the bottom row, you're going to multiply by what's in the box. 6 times -8 is -48. You add those together, and you get -7. We multiply, and I got 56. I add these together, and I have 0. So from the numbers at the bottom, they multiply to what's in the box. Then you add, multiply, add, multiply, add until you're finished. When we go through the next one, that's going to help you out as well. So then you have to know, what is your answer? How do we get to what our actual answer is? And I look here. The number at the very end is our remainder. In this case, our remainder was 0. Okay. And then you're going to work your way back, and you're going to fill in your variables after that. So we have a constant, just like we do here. We have a to the first, just like we do here. Then we get a to the second. So I just put the variables with the numbers, and then I'll write them down. So my answer is a squared plus 6a minus 7 with a remainder of 0. Hey, Jace. All right, so we're going to work through number 2. We'll do this one all the way together. So the first thing we want to look at is see what we need to put in our box. I have p minus 3. So what kind of 3 needs to go in the box? A positive 3. Okay. Then I'm going to write my coefficients across. You always go from highest power to lowest power. You need one number for every single power. This one has it all, but we'll see in a second what needs to happen if we don't have one. So I'm going to write my coefficients. 9, -22, -20, and 16.
Where you get 3 from? That's in that little box.
Right here, what we're dividing by.
Okay.
Yep, you always change the sign of what's in those parentheses. And then leave a space because we're going to fill it in. Okay, and the very first thing we do is we drop our first number. Our first number is 9. So I'm going to drop the 9. And then we multiply. 9 times 3 is 27. So we put 27 in our next position. 9 times 3 was 27. Okay, then we're going to add these two together.
Why do you multiply 9 and 3?
We multiplied 9 and 3 because if you were actually writing all of this out and doing all of the division, it's kind of like I picked that number that was going to be on the top of my division bar, and then you have to multiply it by the number that's in the front to figure out what goes underneath and subtracting. So that's why it happens, but you always multiply whatever's on the bottom row times whatever's in the box. Okay. The negative 22 plus 27 is what? 5, good. And then we repeat the process. 5 times 3 is 15. 15 plus negative 20 is what kind of 5? It's negative 5, good. Negative 5 times 3 is negative 15. 16 plus negative 15 is positive 1. So our last number is always the remainder, and we are going to fill in our variables going from negative 5 up to 9. So negative 5 is our constant. We have just a p to the first, and then we get p to the second. So our answer would be 9p squared plus
Why
5.
negative 5 don't have a p?
Huh?
Why does negative 5 don't have a p?
Because it's like the last number. The very last number in a polynomial doesn't get a variable. Like we had here and here. And this is how you write your remainder. You can either write remainder 1, or we write it as a fraction. So we put plus whatever the remainder is over whatever we divided by. So that is a remainder. That's what we divided by. Okay, the next one I'm going to get set up for you guys, and then we're going to see, actually, no, I'll work the next one, and then the one after that, I'll have you guys do on your own. Give it a try. So if there is not a term for every single power, you have to use a placeholder. So when we are missing a term, we've got to use a placeholder. A placeholder is kind of like the difference between, is there a difference between 45 and 4005? Yeah, they both have 4s and 5s, but this one is telling us that I don't have any in the tens position. I don't have any in the hundredths position, and the 4 goes with the thousandths, right? These are kind of our placeholders there. These zeros are placeholders for the tens and the hundreds. So we have to put zeros if we're missing a power. Which power am I missing on number 3? I am missing the squared term, right? I have a 4th power, a 3rd power. I don't have a squared power, so I'm going to need to put a 0 in that position when I write my coefficients out. Okay? All right, so what's going in my box? Positive 7 goes in the box. Then when I write my coefficients, I have 1 is my 4th power. Negative 7 is my 3rd power. And I didn't have a squared, so I need to put a 0 in the squared position. Okay? First power is 1. Constant is 2. There was no squared, so I had to put a 0 in that spot. Thumbs up if that makes sense. Okay, just like here, we had to put zeros there for those two. So now we're going to run through the process again. The more you do these, the quicker it gets. So we're going to do what with the 1? Where does it go? Drop the 1. 1 times 7 is 7. Add them together. -7 plus 7 makes 0. 0 times 7 is 0. This one's kind of fun. There's a lot of zeros. 0 plus 0 is 0. 0 times 7 is 0. 1 plus 0, 1. 1 times 7, 7. And then what do I do with the 2 and 7? Add them. 2 and 7 makes 9. And 9 is our remainder. I'm going to work my way back. This was constant, first power, second power, and third power. So constant, first, second. This one we had 4 to start with, so we ended up with the third power in our answer. So our final, yes.
So you divided 7 by all the numbers?
No.
All the numbers on top, or what you do?
I didn't divide 7 into anything.
So how did you get the 7007 in?
I dropped a 1. 1 times 7 is 7. Then I added these together and got 0. Then I multiplied, got 0. Added, got 0. Multiplied, got 0. Added, got a 1. Multiply, got 7. Add and get 9.
That's weird that it's called dividing and we not dividing though.
Isn't that weird? Mm-hmm. So when we write it, yes.
I don't know how you got the 0 that's like on the first line to start with.
This one?
Yes.
Okay, I didn't have an R squared term. There are no R squareds. It goes 4, 3, and it skips the 2. So I had to put a 0 there to represent this is the squared term. There's not one of those. So
and
if
as
you're
far as the
missing,
1, you got it from the R.
huh? From the very
As
top?
far as the 1, yeah.
And the 1 is from the R, yes, and the 2 is from that too.
Okay.
So
wait, why is my -2? Don't they switch?
Only the one that you're putting in the box. Nothing else switches.
Oh.
Everything else stays the same. So for your final answer, you'll write R cubed. We skip the zeros because 0 and 0, we don't need to write those. Plus 1 plus 9 over, and what did you divide by? R minus 7. Okay, I'm going to get you guys set up on number 4. We're going to put all the numbers on the first line, and I want you to give it a try. Multiply, add, multiply, add, multiply, add till you're done. So y'all can write the problem down real quick. Okay, what's going in my box? -2. Good. So -2 is going in my box. That would have been my 0 or my root, you know. Then I'm going to look and see if I have all my powers. 4, 3, 2, 1. And then what am I missing at the end? The constant, right? The one that doesn't have a variable. So I'm going to have to put a 0 at the very end for this one because I'm missing the term without the variable. There's not one of those, and I need to have it. So I'm going to go 1 for my fourth power, 6 for my third, 8 for my second, 1 for my first power, and then I don't have a constant and I need 1. Constants are the ones without the variables at the end, so you've got to have that at the end. All right, guys, go ahead and give it a try. See how it goes. Oh, Jayla, put the 0 at the very end for your last row or last column. Add that 0 on there. Let me do it real quick. I haven't done it yet. Layla, that looks good. I couldn't really see the very last line, but your bottom row of numbers was good on your synthetic division part. Taylin, awesome. Now write down what the polynomial would be. Everybody should be giving this a try. Mackenzie, good. Anna, come a little closer. Oh, Anna, on your first multiply, when you did 1 times -2, you should have a -2 under that 6. Okay. April, come a little bit higher. You need to drop the 1 at the very beginning. Drop your 1 down, and that's what you start to multiply with. So you'll do 1 times -2 first, and that goes under your 6.
Yes, ma'am.
Okay, good. Jayla, raise it up a little bit. Okay, when you added 1 plus 0 on your 4th column, 1 plus 0 is 1. Jackson, your numbers are good. Your variables just need to be scooted over. You forgot to put a box around the remainder. You don't use the remainder when you're adding the variables with it. So if you just scoot it over, it'll start with x cubed instead of x to the 4th. All right, the numbers are good, Jayla. We'll work on the variables in a second. Amari, make sure that you put a negative with the 2 in the remainder. But other than that, it's good. Shalia, that looks good. All right, so let's go ahead and work through it. Let's see if whatever little mistake you made that we can fix so that you're not making those later on. But it's good to make them now so that you can get all those questions out of the way. So our first thing that we're going to do is drop the 1. And 1 times negative 2 is negative 2. Add them together and we get 4. Multiply, negative 8. Add, 0. Multiply, 0. Add, 1. Multiply, negative 2. Add, negative 2. So I immediately box this and tell myself it's the remainder. It does not get used when I'm adding my variables to it. So there's no constant. I mean, there's no b on this one. This is the constant, sorry. Then we have b to the first, b to the second, and b to the third. Here's kind of a hint for this. We started out with b to the fourth, right? And we're dividing by 1b. So b to the fourth, if we take 1b out, we're going to have 3 left over for that. So if you're doing, it's always going to decrease by 1 power from your original polynomial when you're doing synthetic division. So b to the third plus 4b squared. We don't have to write the 0b, but it wouldn't be wrong if you did. Plus 1 plus negative 2 over b plus 2. So that is just doing the synthetic division. There are 3 types of problems where we use this, where they ask us a question or ask us to factor something, or they do something that's called the remainder theorem. So now that we know the synthetic division part, these other ones are a lot easier to do. They're pretty quick since we've gone through that process. Okay. So sometimes you'll be asked if the factor or if the binomial is a factor. So if you are asked to tell if the binomial is a factor, if you're asked that question, you do synthetic division and you check the remainder. What should the remainder be if something is a factor? A factor means it divides evenly. So if something divides evenly, what is the remainder? 0, right? So if you're thinking about any number, is 3 a factor of 12? Does 3 go into 12? Yes. If you divide 3 into 12, you don't have anything left over, right? No leftovers, no remainders. So to tell if something is a factor, oh, that underlined on its own, that's fun. You are going to divide and check the remainder. The remainder needs to equal 0. If the remainder is not 0, it is not a factor. So we can just do this first one real quick. We don't have to work both of these once I get this fixed. One day it'll all work for me, maybe so. So if they say, is n minus 3, is that a factor of this? We divide and we check and see what the remainder is. So what's going in our box? 3. Do I need any placeholders? 3, 2, 1, nothing. Do I need a placeholder? Nope, I'm good to go. So 1, negative 11, 26. That's a positive 26. Ignore that negative sign. Then negative 7. Don't draw that dot on your paper. I just can't use the eraser tool. It'll all mess up. And all we're doing is checking the remainder. Drop our 1. 1 times 3 is 3. 3 plus negative 11 is negative 8. Negative 8 times 3 is negative 24. 26 plus negative 24 is 2. 2 times 3 is 6. Is my remainder going to be 0? Nope, my remainder is negative 1. So this is not 0. So not a factor.
What's that big circle there before the 26 for?
I wrote a negative on accident and I was trying to scribble it off.
Okay.
Yeah. Just a mistake on my part. So the remainder is not 0, so it is not a factor. Right? If the remainder is 0, it would be a factor. The next one does have a remainder of 0, but we don't need to work it out. Right? Y'all are good? 0, yes. Not 0, no. Okay. Just factors means it divides evenly. That's good. This next type is kind of fun because they give you one of the factors and then they want you to use it to keep on factoring the problem. So it's a problem that we don't have any tools to factor yet. It's not a quartic trinomial. We can't do grouping. That won't work out. So what we're going to do is we're going to divide our factor out first using synthetic division. Then whatever we have left at the bottom, we'll have a quadratic at the bottom. We're going to factor that. So we'll do this problem next, just like we did before, but you'll get something at the bottom and you just break it into 2 factors. So nothing new for the next type. So we are going to factor completely. They give us a problem and they tell us x minus 5 is one of our factors. So when we divide the x minus 5, what remainder should we expect to get if we know it's a factor? What remainders do factors always get? 0, yes. So we're going to divide this using synthetic division. We'll get a remainder of 0. And whatever's left at the bottom, we're just going to keep dividing. Keep factoring, sorry, not dividing. So what's going to go in our box if I had x minus 5? 5, good. We got 1, -6, 3, 10. Oh, I didn't check, but let me see. 3, 2, 1, 0. Okay, no placeholders needed. Drop the 1. 1 times 5 is 5. -6 plus 5 is -1. -1 times 5 is -5. 3 plus -5 is -2. -2 times 5 is -10. And we got a remainder of 0. Sorry, I did that one kind of quickly. I just want you to see what happens after the fact. We know the synthetic division part right now. Okay. So now I'm going to give the variables. This is our constant, this is our x, and this is our x squared. So x squared minus x minus 2 is what's left. So when I divided x minus 5 out, this part's left. So they want me to factor it completely. So when you have a quadratic there and your remainder is 0, we'll just factor it like normal. So what multiplies to 2? 2 and 1, right? I want a -1 in the middle. So which of these needs to be the negative number, the 2 or the 1? The 2. It's a negative and a positive. So our final answer to be factored completely, our first factor was x minus 5. And these are our second 2. So our final completed answer is x minus 5 times x minus 2 times x plus 1. So we use the factor they gave us initially. That's one of them. And these are our other 2 factors. So if they ask you to factor it completely and they give you 1, divide that. Whatever's left over, you'll then factor. So the only thing additional from our other synthetic division problems was you just factored at the end, whatever you got. That doable? Once you get your quadratic factor? Okay. The very last thing, this one's kind of just like a party trick, really. It's called the remainder theorem. The remainder theorem says that a cool way for you to evaluate a function, like to figure out what it would be if I plugged 3 in for all of my numbers, I could plug 3 in and put that in the calculator, or I just put 3 in the box, and whatever the remainder is the same thing I would get as if I just plugged it all into the problem. Okay? So for the remainder theorem, you put your number in the box, and the remainder is the answer. That's just a straight mark. We don't change the sign with the remainder theorem because there weren't any parentheses, or it wasn't like x plus or x minus. They just give you a single number. So it's kind of like them saying, here's the root already. You don't have to change the sign. We just put it in the box. Whatever you get for your remainder is the same thing you would have gotten if you plugged the number in to each of the variables. Okay, so f of 3, like plugging 3 in, is going to be the same thing as if I put 3 in the box and synthetically divide. So we can do it quickly. 3 in the box, I don't change the sign because it wasn't in x plus or x minus form. Use my numbers. I know I'm going quickly at the end. I want you to have a little bit of time to work. Drop the 6. That's 18. That's -5, -15, -4, -12, -7. -7 would go here. If you plugged in 3 and for all of those A's and put that in the calculator, you would get -7 for your answer. So you could do that, or you could use this technique where you just put that in the box, don't change the sign, and your answer is going to be whatever your remainder was. So these are the ways that we use synthetic division in our math problems. To tell if something's a factor, to factor completely, to evaluate for numbers. Okay. And obviously for this homework assignment, you can't just look at it and write the answer down, right? You understand that? I need to see the synthetic division for all of your problems. So start working these out. Let me know what questions you have. If you're getting stuck or not getting something, show it to me and I can help you see if I can figure out where your mistake was in your problem. Sometimes it's just negative and positive errors.